This is the notes for 3.1, solving equations. Our scenario says Miss Chang's class decided to use Wee's tees to make their t-shirts. The following equation represents the relationship between the cost C and the number of t-shirts N. So I'm putting in my number of t-shirts and I'm getting out my cost. Okay, so what this is saying is it's $3 per shirt, and what I'm getting out is my cost after I add my flat fee of $10. So there's some type of design fee, so that if I wasn't going to buy any shirts, they would still charge me the $10, but then after that it's only $3 for every shirt. Our class wants to buy 25 shirts. Describe how I'd use a table and a graph to find the cost. Okay, so let's just start with 0. Remember, if we put in 0, I'll get out 0, but I do still have to pay that flat fee of $10. If I buy one shirt, $3 times 1 is 3, but plus 10, they would charge me a bill of $13. If I put in 5, 3 times 5 plus 10. So $3 times 5 shirts is 15. I add my flat fee of 10. I have to pay $25. 10 times 3 is 30, plus 10, 40. 15 times 3, 45, plus 10, 55. 20 times 3 is 60, plus 10, 70. And our last one, this is what we're looking for. 25 times 3 is 75, plus 10, and I would get $85. Okay, so how can I use the table? I'm finding right here at 25 shirts in my table, and I got out my cost was $85. So as you're filling out this table, just keep in mind it's not a proportion. So I can't just take 10 times 3, 15 times 3, 20 times 3. Even though this is a constant rate, my slope is $3 per shirt stays the same. I have to add that $10 fee after. Okay, so every time we're going to go back to this original equation, put in whatever you're finding, times 3 plus 10. All right, now let's look at the graph. Since I want to get all the way up to 25, I know I can't count by ones. I'm going to be a little short. But if I count by twos, then we'll have even more kind of falling in the middle. It looks to me like they're counting by 5s, but I'm going to spread it out. So instead of every one by 5, and then my graph only being right here, I'm going to go and spread it out. So like every third one, I'll put 5. So there's 5, 10, 15, 20, and there's 25. Okay, so I'm just spreading it out a little bit. Since they counted for number of shirts by 5, I'm putting number of shirts in across the bottom. I know I want to count by 5s, but I just spread it out a little bit so that way I could see more of my graph. If you went 5, 10, 15, 20, 25, that's okay, but then your graph is only going to be this part right here. I just spread mine out a little bit. Okay, and then my cost is what I'm getting out. So on my vertical one, I know I need to count all the way up to 85. So I'm going to go ahead and count by 10s. 20, 30, 40, 50, 60. Okay. So remember, we can count by different things. That's okay. These ones counted by 5s, and I just spread them out a little bit. And then these ones counted up here by 10s. I wanted to get out 85, so I counted by 10s this way. Versus what I was putting in, it's okay that that one counted by just 5s. All right, so let's go ahead and graph them. At 0 shirts, I paid $10. At 5 shirts, it costs $25. For 10 shirts, it costs $40. For 15 shirts, I got $55. For 20 shirts, I paid $70. And for 25 shirts, I paid $85. So remember, everything this unit is a straight line. If you've done it correctly, I should still have a linear function here, right? But since I started at 10, that's why it's not directly proportional anymore. So my whole graph shifted up 10, and then I was going $3 per shirt, $3 per shirt, $3 per shirt. Okay, so to find my graph, it's just this ordered pair right here. If I put in 25 shirts, and I got out $85. All right. The other questions you're going to look at today deal with the slope and the y-intercept. So again, just to review, the cost per shirt. That's what we call our slope. Where we see that on the table is what I add. So in this case, I added $15 for going 5 shirts. So we could say $15 per 5 shirts. That equals my slope of 3, right? Or I could see it like right here, from 10 to 13, I went up $3, but that time it was only for 1 shirt. So this is a linear function. I'm adding 3 to every 1, or in the case of if I went from here, right, I could add 12 for 4, or that's the same as 15 divided by 5. Every scenario, my slope is 3. And then we can also see that in the graph. So I would go between 2 good ordered pairs. So from 10 to 40, I went up $30, but that was after buying 10 shirts. Okay, so again, all of these rates, guys, are simplifying to be the same. $30 divided by 10 shirts, $15 divided by 5 shirts, $3 divided by 1 shirt. All of those slopes are a constant rate. And my graph is how much I go up and then over. And my table is how much I'm adding from this is what I'm putting out, so my dependent to my independent. And my equation is what I multiplied by. Okay. The other thing we find is the y-intercept. And that tells us where we start. So if I put in 0, I would get out 10. I can see that in my table and my graph as well. I'm putting in 0 and I get out 10 for my starting point. That's my y-intercept.